Hi everyone, I'm Ranjit Ramchandran and this is my first video for my channel Always Learn New. I have a working experience of 17 years and I'm a working professional, and my main motto to create this channel is to give new information about information technology. And this video, since uh, it's the first video, I have chosen application gateway as a topic to give you more information. Many of you may be knowing about it, and for the people who are new, for them it's just they can learn about it. If you want to make a career in Azure, and if you're going to give exam on AZ104, so you will come through this term called as application gateway. So without wasting time, let's start and let's begin the session. So just run the slide and here goes. So application gateway. So I'll be telling you about its uses, its features, about the application gateway. So going forward, there are a lot of can say there are different types of load balancers in Azure. So every load balancer gives different features or support. They support in a different way, and you can use it whenever what kind of a scenario or what kind of an architecture your organization is having. So the application gateway basically is used for HTTP or HTTPS traffic, but it's recommended for the HTTPS traffic, and it's a layer 7 load balancer. So if you see, there are many other load balancers which are used in some scenarios. In coming slides you will see that the organization we use application gateway along with other load balancer, or they may have a mixed type of usage. But I will be taking basically about only about application gateway only. I won't be in this video, I won't be explaining you about other load balancers. So I will be focusing mainly on application gateway. So if you see, what is an application gateway? Application gateway is a layer 7 load balancer, and it manages the traffic of web applications. The traditional load balancers work on layer 4, and the routing is based on IP addresses, the source IP and the destination IP address, and the port associated with it. So if you see the flow of the application gateway over here, so this shows the application gateway. So in my video you will see I am using application gateway and Azure Firewall. These two things are used. Along with the load balancer, we can use Azure Firewall. So there are some scenarios wherein I'll be using both of them for the design. So here if you can see, the HTTPS traffic coming from the internet or the on-premise network to Azure is taken care. It goes through the application gateway and the web application firewall. Application gateway has a built-in firewall. It's if you don't want to use the web application firewall, you can you need not configure it. But usually they use most of the organization use web application firewall along with the application gateway. So the application gateway uh, doesn't look for the HTTPS traffic coming from the Azure to the internet or to the on-prem, and non-HTTPS traffic from internet or on-prem to Azure. Similarly, non-HTTPS traffic from Azure to internet or on-prem. So these traffics are not taken care by the application gateway. Going further, this is the application gateway architecture. So the web application, it goes from the HTTP. If you're using the HTTPS, it will hit the web. Is the application gateway over here, you can see, and the web application firewall, and then it is passed to the respective application services. So there are a lot of configuration done over here. If you see here, when it starts from here, the application is accessed from the internet via HTTPS. And if it's not an HTTPS, it will be sent to Azure Firewall. And if it's an HTTPS application, it will be sent, it will ask for uh, the IDPS is nothing but intrusion detection and prevention system. It monitors if it has any got threat or anything. Basically a firewall. It will be checked, and if it is required or not. If you want to whatever traffic comes from the internet, if you want to get it checked, then it will go through the application gateway with web application firewall on it. It will be in the front end, and after that it will be passed to the Azure firewall. If you don't need to be detected, then it will go through the application gateway and the web application firewall and Azure firewall in parallel. There are two uh, kind of a scenario here it is shown, wherein if it has to be detected, you will see here the application gateway and the web application firewall is in the front of Azure firewall. Whereas if you don't want the intrusion detection, then the web application firewall, WAF, and the application gateway and the Azure firewall are in parallel. So this situation you will see in coming slides. So this kind of architecture would be there. This kind of, but the basic architecture is like if the web application comes from the internet, it goes to the web application firewall over here along with the application gateway. It's filtered over here, then it is passes to the backend servers. So that is the main basic architecture. So how an application gateway works? How an application gateway works? A session from the end user terminate on the application gateway, and the application gateway initiates the connection to the backend servers. You mean the backend web server, or you can say whatever applications are there. If you can see here, the users, they send in a request. So before the user sends a request to the application gateway, it resolves the DNS. It resolves the domain name of the application gateway by using a domain name system. So if you can see here, once the request is sent, it will hit the application gateway. The DNS is already doing its work, and these are some of the features, not the feature, the components that are configured in the application gateway. The listener, the rules, front-end IP, the front-end ports. So these things are uh, configured in the application gateway. So the application gateway will have uh, one public IP or one private IP, or it can have one one public IP and one private IP, or it will just have a one public IP. So when the user uh, so before the client sends a request to the application gateway, it resolves the domain name of the application gateway by using a DNS. So the Azure controls the DNS entry because all the application gateways are in the domain of the Azure. So the Azure DNS will return the IP address to the client, which is the front end address of the application, front end IP address of the application gateway. So the application gateway will accept the incoming traffic from through a listener. So listener is where the port of HTTP or HTTPS is configured. The listener is a logical entity. It checks the connection request. It is configured with a front-end IP address, protocol, and the protocol number for connecting connections from the client to the application gateway. So if we have a web application firewall, so there will be some rules in that firewall configuration. So it will check the request header and the body. So if it is against the web application firewall rules, so it will check if there is any security threat or anything. So if it is the request is valid, it will be routed to the backend servers that is over here in the virtual machine or wherever the request has come from. So it will go to the backend pool and it will be forwarded there. But if it is in detection mode, that it will just detect it and it will check, and once it will still forward the request to the backend servers. So it depends. So Azure Application Gateway can be used as an internal application load balancer or internet facing application load balancer. So it basically uses a public IP address. So it will resolve the public IP address, and the internal application gateway use only private IP address. So if we are using a custom or a private DNS zone, the domain name should be internally resolvable to the private IP address of the application gateway. Therefore, internal load balancers can only route requests from client which access to virtual network for the application gateway. So if you see over here, there are many other things that are configured see. It's let's go back. Okay, so if you see over here, uh, in the listener, after it goes to the listener, there are some rules with the port 80. You will see uh, health probe is configured to know whether the listener is active or the network, the request is uh, sent, and if it's listening, so the health probes are configured. So and this is the backend pool over here. You can see all the application services, application servers over here. So what I was talking about the front end IP. So if you see, if the backend pool, that is the backend pool, if you can see the virtual machine and the other servers, if the application gateway is using the front end public IP to reach the server, and if there isn't a front end public IP address, so one is assigned for the outbound external connectivity, and if it is an internally resolvable FQDN or private IP address, the application gateway routes the request to the backend server by using its private IP. So it will have both public and private IP. So to which where it communicates. So it will have both external endpoint or externally resolvable FQDN. So the application gateway will route the request to the service via its private IP addresses. The DNS resolution is based on private DNS zone or custom DNS zone. So the application gateway will route the request to the backend server by using its front-end public IP address. If the if the request is external, if the subnet contains the service endpoints is external, so it will use that. If it's an internal one, it will use a private IP address, front-end IP. So going forward, these are the application gateway components you can say which are configured the front-end IP address. So the front-end IP address is configured. It could be virtual IP. So and for when front-end IP and the listeners, there are two types of listeners: basic or uh, multi-site listeners. Ports are configured. Protocols are configured. For example, is it HTTPS or HTTP? And routing rules are configured over here for the backend pools. Uh, Certificates are set up. If you can see, certificates are done installed in the configured for the listener side. So you can see the front end listener is with the port, IP, and the certificate. So if you can see the backend pool over here, the backend pool has to be configured, the servers to whom to which it will connect, the health probes. So it has various components in it. So the front, if you see, the front end IP address is IP address that is associated with the application gateway. So when you configure the application gateway, you have to provide the public IP address, a private IP address, or both. So the application gateway supports one public IP or one private address, a private IP address. So your virtual network and the public IP address must be in the same location where your application gateway is. So once it's created, the front end IP address is associated with the listener. So the IP, so the IP could be static or dynamic. So it will support both static and static internal IP address or static public IP address or only static public IP. It cannot be configured to support only static internal IP address. Okay, so if you see the listener, it's a logical entity that checks the incoming connection request. The listener accepts a request if the protocol, port, or the host name and the IP address associated with the request matches the listener configuration. So, if you are configuring an application gateway, you must add at least one listener, or there could be multiple listeners attached to an application gateway. So once the listener detects the incoming request from the client, the application gateway will route this request to the backend pool as per the configuration in the rule. So that is the this feature. And the ports, its port range, it supports for 1 to 64,999 and 1 to 65,502. So, uh, these ports within this port range, it supports HTTP, HTTPS, and HTTP slash 2. So these things are configured, and if you go for, there are two types of listeners in that. One is the basic one, and there is a multi-site listeners. So there are other things that are configured in this. One is if you see here redirection support, it will help in the redirecting the traffic as per the rules. HTTP headers and rewrite the HTTP headers and URL. You can add, update the response headers as well as the URL path in it. You can request routing rules in that. Health probes. It will monitor the health of all resources in its backend pool, and it removes the unhealthy ones automatically. And these health probes are required for monitoring the backend requests. Whatever backend request comes in and goes, it will check the requests. So if you see, the application gateway has so many features. There is secure socket layer termination, auto scaling, zone redundancy, web application firewall. It has got static virtual IP, ingress controller for AKS. It can do URL based routing. It can do multiple site hosting, redirection facilities there, session affinity, WebSocket, and HTTP2 traffic. Also, it can connection draining, custom error pages. rewrite HTTP headers and URL sizing. So there are the application gateway can do a lot of things. Since this is an introduction video to application gateway, I won't be going through all of these features, but I can maybe I can tell you few features of this like auto scaling. This application gateway it supports auto scaling. It can scale up or down depending upon the traffic load patterns, and it will scale up or scale down if there is a heavy network. It will act accordingly. That the application gateway. So that is a feature of the load balancer. This is the application gateway is nothing but a load balancer. So it will balance the load. And web application firewall, you are aware that it's a service that provides centralized protection to the web application, and whatever vulnerabilities or any exploits that can come through the common known vulnerabilities will be blocked, like SQL injection attacks, cross-site scripting attacks. There are many things which can be there. And if you see ingress controller for AKS, that is one of the feature which is used in AKS to in Azure Kubernetes Services cluster, and it is also used for the load balancing in the cluster where the Kubernetes is set up. So let's go further. So there are two versions in application gateway. I can say basic and standard. If you see over here, it depends upon the functionalities. The basic functionalities over here, you can see HTTP, HTTP2. So what all things it supports, and functionality in advanced. If you see here, the basic ones doesn't support in the AKS URL rewrite. In the maximum connection, it has the number of backend pools. It supports the standard SKU. So there are two SKUs available. If you go for the latest one, if you compare between the SKU 1 and the SKU 2, so there are many features regarding the, if you go in SKU 2 version 2, you find auto scaling, zone redundancy, static virtual IP, AKS ingress controller, Azure Key Vault integration, rewrite HTTP headers, URL based routing. I guess URL based routing is available here also, but if you see, there are some of the features which are not available. If you see the web application firewall, it's also available in basic version 1 and version 2 both. But I guess the new features is we have custom rules. So there are a lot of features you can compare and see here. I'll not be going through each and every features of this. Maybe in my coming videos I will go deep in the application gateway, regarding the application gateway, and more about it, and other load balancers also. So going forward, the application gateway, in what kind of a scenarios it is used. It can be used if there are no web applications. If there are no web application, the virtual network, it will control both inbound traffic to the applications and outbound traffic. So in that case, only Azure firewall is only used, no application gateway. If it's only a web applications in the virtual network, and in that case, application gateway and network security groups are sufficient enough to do the filtering, and the functionalities provided by the Azure firewall. It will prevent many attacks, so you can use the Azure firewall also along with that. So you can see here in the some scenarios, Azure firewall and the application gateway are parallelly used, wherein these are the common design where the combination of application gateway is used to protect the HTTPS application from web attacks, and Azure firewall is used to protect the other workload, or it will filter the outbound traffic where the application gateway doesn't play a role. And in some scenarios, application gateway is in the front of the Azure firewall, wherein Azure firewall will inspect all the traffic. We have to protect the web traffic and the application to know the client source, wherein the firewall will check the other things. And in other scenarios, the Azure firewall will be in the front of the application gateway, where it will inspect and filter the traffic before it reaches the application gateway, because the Azure firewall isn't going to decrypt the HTTPS traffic, and the functionality adding that is adding to the application gateway is limited. So I have just given you some scenarios, common scenarios how the application gateway is used. So if you go just with the Azure firewall alone, where there is no application gateway, then the entire traffic routing is carried out by the Azure firewall itself. You can see here in the design, the inbound traffic is sent to the Azure firewall. We're using the user-defined routes. In the Azure firewall, you will see the public IP is there, and it will also have, it will attract it to the internet, the direct internet facing. You can see the outbound traffic is sent to the firewall by the user-defined routes. So here in this case, there are no web applications. It will control both inbound and outbound traffic to the applications. Here there is no web-based applications. So if you go the next scenario where there is only the application gateway along, you can see here the application gateway along with the NSG is configured. So, but this kind of a scenario is usually not recommended, because for the outbound traffic, you need the Azure firewall, uh, because just with NSG it is not sufficient to protect many scenarios. So this is a scenario wherein the mixed of a scenario. You can see the Azure firewall, and here you can see application gateway with WAF. So the Azure firewall and the application gateway are in parallel, which is a common design. As I informed earlier, it will protect the HTTPS application from web attacks, and Azure firewall will protect all other workloads, that it will filter the outbound traffic. So it's a mixture. If there is a mixture of an environment where is a web applications and non-web web workloads are there, so the Azure web WAF it will protect the inbound traffic to the web workloads, and the Azure firewall will inspect the inbound traffic for other applications, and the Azure firewall will cover the outbound flows from both workloads. So if you can see here, whatever goes out, it will go out using the Azure firewall. So this is a common scenario which is used in the industry. So going further, if you see the application gateway is kept in the front, wherein it will go through the application gateway and it gets filtered. It goes to the application firewall and it goes to the Azure firewall also. And later it is sent to the client. So in this scenario, the application gateway is in front of the Azure firewall and it will inspect all the traffic. The WAF will protect the web traffic and the application, the client IP will check the source IP with the Azure firewall. And in this, you can see in this structure, the inbound web traffic goes both through both Azure firewall and the web application firewall. The WAF will provide protection to the application layer, and the Azure firewall will act as a central login and control point. Will inspect the traffic between the application gateway and the backend servers. So the Azure firewall aren't sitting in the parallel but one after the other. In this case, the application gateway is in front of the Azure firewall. So the Azure firewall will capture the incoming traffic from using with the source IP address and will check so that the web server can see the original IP address in this request. So the inbound connections coming from the internet need to be sent to the public IP address of the application gateway from Azure or on-premise to the public IP address. So from the application gateway, so user-defined routes will make sure that the packets are routed through the Azure firewall. And for inbound non HTTPS traffic, it will be targeting the public IP address of Azure firewall coming from the public internet, and it will be sent through the Azure firewall using the user defined routes. So if it is coming from other Azure VNets or on-premise network, all the outbound flows from the Azure VMs will be forwarded to the Azure firewall and not to the application gateway. So wherever the traffic is non-HTTPS or it is an outbound traffic, outbound flow from other networks, so it will be passing through the Azure firewall. So wherever the inbound traffic is there, inbound HTTPS connection is there from the internet, it will be sent to the public IP address of the application gateway from Azure or on-premise to the private address from the application gateway. So these two help each other. So in the next scenario, we'll find the Azure firewall is in front of the application gateway. So the Azure firewall, you can see the request first goes to the Azure firewall and it goes to the application gateway, then to the client, and then the client sends a request back to the application gateway, and it goes to the Azure firewall and back to the user. So in this design, the Azure firewall will filter all the traffic before it reaches the uh, client, or you can say before it reaches the application gateway. So it will hit the firewall first over here, whatever request comes in, and then it will go out. So all outbound traffic from Azure virtual machines to the internet will be sent through Azure firewall using a user-defined routes. For traffic from on-premise or Azure user-defined routes, the application subnet should be used. Application gateway subnet should be used. So Azure Firewall in the front of the application gateway, it will filter all the traffic before it reaches the application gateway. So this scenario is also commonly used, and point which you can see it's mentioned over here, the Azure Firewall isn't going to decrypt the HTTPS traffic. The functionality that is it's adding to the application gateway is limited. So that's all from my side, guys. Thank you for listening, and I hope I have provided you some information which you may not be aware of it or which you already know. But like my channel says, always learn new. So I always have a feeling that we should keep learning and stay updated. Thank you for watching the video. If you like my video, please subscribe it. I'll be keep posting the videos, and please do provide me the feedback about this video. It will help me uh, to create more videos and provide you more information in a better way, and spread more information. That's all. Bye, guys. Take care.